Assalamualaikum and good morning to my panel, Encik Hairul Effendi and Dr. Mustafa binti Taha. My name is Mordhiati Zahirah binti Morsal from 4BMMP 1/1. Today I will present my final year project which entitled Cassava Starch Biodegradable Latex Film. My supervisor for this project is Ms. Nuzaimah binti Mustafa and my co-supervisor is Dr. Ridhwan bin Jumaidin. Alright, today highlight is about introduction, literature review, methodology, result and discussion, and conclusion. What is Latex? The introduction of my project is, in recent years, the waste disposal problem has spurred mounting interest in polymers biodegradability, especially when the public is voicing greater concern about protecting human health and preserving the quality of our environment. The ability of microorganisms to degrade rubber waste has received considerable attention. Therefore, biodegradation is an alternative way to degrade rubber waste and could overcome environmental problems. This project aims to analyze the environmental properties of Latex, or also known as biodegradable cassava latex, which the main materials are latex and cassava starch. Numerous testing conducted to obtain the data to meet the objective of the project. Okay, this is a problem statement. When I intend to conduct this project, I will figure the problem that arising around my surrounding and our country. Okay, the first one is the presence of rubber wastes currently result in environmental pollution. As you know, the pandemic COVID-19 is arising day by day. This is contribute the wastes of rubber increases. The second one is resistance to biodegradation of an industrial product can be due to the presence of curing agents and highly effective antioxidant. The third one is rubber is elastomeric and consists of molecules with a higher average molecular weight of nearly 1 million, and it is slow to degrade. So this is the objective. As we know, the problem statement is related to the objective. Okay, the first one, I will formulate a stable biodegradable latex formulation and starch formulation, which related with the arises of the waste rubber. The second one is to prepare the rubber film with different composition of cassava starch. The third one, when we talk about the rubber is a slow degradation, okay, this project will determine the biodegradability of the rubber film. This is my scope of work for this project. The first one is it is emerging a formulation and processes of the preparation of the natural rubber and cassava starch. The second one, process of latex film using dipping method solution. The third one, numerous testing conducted to analyze the environmental properties of latex film. For my chapter 2, literature review, there's a various of previous journal that I will refer. We shall proceed to the next chapter, methodology. Okay, as you can see on the slide, there's materials that I use in this project. The first one is latex, cassava starch, potassium hydroxide, and calcium nitride coagulant. Okay, latex and calcium nitride has been provided by an ex-industry. Meanwhile, cassava starch has been provided in our faculty, and potassium hydroxide provided by FKP. Okay, this is formulation of natural rubber latex. The total compound that I can conclude is 40% of the dispersion. This is the way I conduct my project. The first one, I will weigh the materials. The second one, all the materials were mixed up using magnetic stirrer for 1 hour. The third one, I will dip the former aluminum steel plate and unlace unglazed ceramic plate, which I will dip in calcium nitrate 25% for 50 seconds and dry in oven for 5 minutes, and dip into the dispersion for 13 seconds. Okay, so after that I will dry in oven for 1 hour at 100 degrees C. So I will let it set for 24 hours in the room temperature. This is my flow chart of project. The first one is literature review, and then I will select the material. Then I will prepare my material, coagulant, dipping in coagulant, drying in oven, dipping once again in NRL, then drying again in oven for 1 hour and curing in a room temperature. Okay, we shall move to the next slide, chapter 4, result and discussion. As you can see, this is my water absorption result. As the increment of cassava starch content, the films absorb more water. Okay, this is because the starch is a hydrophilic, which attract to the water compared to the rubber, which is hydrophobic, which neglect the water and only absorb just a little amount. Then this is water solubility result. The highest water solubility is at 20 pHr, which the film soluble in the distilled water, and the lowest one is 0 pHr. This is the sample of water absorption and water solubility. You can see a very fine thin film obtained at the 330 pHr, and the others, the film will accumulate and it's hard to form a thin film. Okay. The last one is soil biodegradation result. As you can see, the highest value of soil biodegradation is at 30 pHr. As I mentioned before, the starch helps the rubber to degrade more faster than usual. Okay, this is my sample of soil biodegradation after drying. My sample were buried in a soil in a poly bag, which buried for 2 weeks and taken out and dry in the oven. I will wash it with distilled water and drying in oven for 1 hour and at 100 degrees C. Then I will wait to get the final waggy. Okay, as we can observe, the rate of the 3 testing will increase parallel with the increment of starch in the latex film. Starch was proven to help the process of degradation. This is because the characteristic of the starch is hydrophilic, which contrasts with the characteristic of rubber, which is hydrophobic. So we should move to the next chapter, chapter 5, conclusion and recommendation. As you can see, there are 3 objectives that I've been mentioned before. The first one is to formulate a stable biodegradable latex formulation and starch formulation. The first contribution is forming a thin film latex, even though using a different former, unglazed ceramic and aluminum flat steel. The second one, to prepare the rubber film with different composition of cassava starch. This second contribution is latex film undergone different testing, which given a numerous of results which explain environmental properties. The third one is to determine the biodegradability of the rubber film. Third contribution is the increment of wet loss in soil biodegradation, which at 30 pHr. Okay, this 30 pHr shown a wet loss in soil biodegradation, testing parallel with the increment of starch added. This is my recommendation for project for the future work. The first one is dipping former. As you know, dipping former has a lot of type. So the dipping former that I use in my project is unglazed ceramic and aluminum steel plate. So I should suggest to study the different formula characterization which affect the properties of latex film. Second one is type of coagulant. Type of coagulant that I use in my project is calcium nitride, which mixed with water. So I should suggest to study the different type of and concentration of coagulant such as ethanolic calcium nitride. The third one is type of process. So in forming a thin film of latex film, there are various of process. So I should suggest to study the various type of forming a latex film such as hot press or solution casting method. Okay, that's all from me. Thank you for listening.